Okay, this lecture is exponent rules. This is not exactly in the book. The book starts out with, I believe it starts out with exponent rules for fractional exponents. The rules are the same, but they're a little easier when you don't have fractions. So here are the rules, and I'll walk over them pretty quickly. This is some review. I guess the first thing I want to make sure is everybody understands that what the base is. If I have something that would be 8 to the 4th power, that the base is 8 and the power or the exponent is 4. And if I would have something where I would have 8 to the 4th divided by 8 squared, a lot of people are tempted to divide these 8s and say, okay, that's 8 divided by 8 is 1, 4 minus 2 is squared, so that's 1 squared, and that's not the case. We think about this, that'd be 8 times 8 times 8 times 8. 8 squared is 8 times 8. So if we cancel those out, you can see I have left is 8 squared. So how it works when I have exponents is I don't divide the bases. I simply subtract the exponents in this case. So the base stays the same and the exponents add or subtract. You cannot combine things that have different bases. For example, x cubed, y squared. The bases are different, so those exponents won't combine. Now, it's slightly different if I'm doing something with, say, scientific notation, and I'll try to show you the difference between that and what we have in just the pure exponent rules. If I would have some sort of a problem that would say 1.6 times 10 to the 5th divided by 3.2 times 10 squared, in this case, I have the same base, so at the end here, I'm going to have times 10 to the 5 minus 2. And then I'm going to have 1. Now, these are not exponents, don't have exponents. Those will divide. The number parts will divide, and I would have 0.5 times 10 cubed. Okay? Which, of course, if you change that, that would be 5 times 10 squared. So remember, on the exponent things, the bases stay the same and the exponents do whatever they need to do. On number parts, you just simply treat them like you do numbers. Okay, so let's go ahead and go over the exponent rules quickly. And then I'll work out quite a few problems. As we have the product powers, the product of powers property, that's when I have anything that has the same base and I have exponents on it, I simply add the exponents. That would be a case like, let's use 4s. 4 squared times 4 to the 1 is 4 cubed. Okay, if I have a base to an exponent and that's taken to another exponent, then those exponents would multiply. That would be simply a case like if I had 4 squared and then that cubed, that would be 4 to the 2 times 3 is 4 to the 6th. That case, the exponents multiply. If I have two different bases and they are both in parentheses to a power, then that power distributes. An example would be xy squared. That would be x squared y squared. Anytime I have a negative exponent, I don't want to leave it as negatives in my answer. So what I simply do is I take the exponent and make it positive by moving it across the fraction line. So say, for example, I have a to the negative m. I get rid of the negative. I move the a and the m across the fraction line, and it works both ways. For example, if I have x to the minus 2, that's 1 over x squared. If I have 1 all over x to the minus 2, then I don't want to have the negative 2 in the answer, so I would move the x to numerator position and the negative would go away. So to get the negative off the exponent, you just simply move it across the fraction line. Anything to the 0 power is 0. X to the 0 is 0. 1,000 to the 0 power is, 1, not 0, 1. Anything to the 0 power is 1. So x to the 0 is 1. 1,000 to the 0 power is also 1. Whenever I have two bases and one's in the numerator, one's in the denominator, they're the same base, then my exponents subtract. And really I want to look at the largest exponent. I don't want negative exponents. So say, for example, that I have a situation where I have x squared all over x to the 4th. I could say this is equal to x to the 2 minus 4, but then now I have a negative exponent, so that would be 1 all over x squared. A simpler way to do it is just look at where the biggest exponent is and subtract those exponents. So, for example, 4 is larger than 2. 4 is in the denominator, so I would take 4 minus 2. That would give me 1 over x squared. So wherever I have the largest exponent, then that's where the base will be. So it gives you the same answer both ways. The last one is simply just distributing the exponents again into division. Okay? Let's work problems. So the first one is 3 to the 6th all over 3 squared. So I'm going to say that is equal to 3 to the 6th minus 2. That's equal to 3 to the 4th, which is 81. Now we're not going to use any calculators in this. So simple exponents like that, you can evaluate, do it. If you have like 5 to the 6th, leave it as 5 to the 6th. I don't want you using any calculators. This would be 2. Now these are exponent to an exponent, so that would be 3 times 2. 2 to the 6th, that's 64. Going to the next one, this would be 8. Now the same base, and they're multiplied together, so that would be 3 plus 1. It's 8 to the 4th. I don't know what that is off the top of my head. I'm leaving it in exponent form. D is 2. We'll distribute the exponent in. 2 cubed all over 3 cubed. 2 cubed is 8. 3 cubed is 27. Working some more. A negative 2, now that's going to distribute in, so I'm going to have 1 to the negative 2 power, 5 to the negative 2. Okay, to get rid of the negatives on the 5, it's going to have to move up to a numerator and be 5 squared. The 1, which has a negative 2, would move down to the denominator and be squared. That would be equal to 25 all over 1, be 25. Next one. They have the same base, so the exponents add. That would be 3 to the 6th. I do not know what that is. So I'm going to leave it, not use a calculator. Anything to the 0 power is 1. Three to the minus 2. So I'm going to take the negative off that 2, so I'd have to move the 3 to a denominator, move it across the fraction line. That'd be 1/9. Now I'm going into some variables, so I'm not going to be able to evaluate them with numbers. So for this one, I have x, a negative 3 to the 4th power, so those would multiply. That's x to the minus 12th. Y to the 2 times 4 is y to the 8th. Okay, so now we have a negative exponent. Let's get rid of that negative by moving the base across the fraction line. So that would be 1 over x to the 12th, y to the 8th. Pretty easy. Once you get the hang of it, you can really move pretty quickly on these. This one's got a negative exponent in there. Let's do this one, m. So that would be 2. Negative 2 times 3 is a negative 6. And then I've got 2 to the 5th out there, so the exponents are going to add together. There's no need to move the 6 to the denominator since both the bases are the same. That's going to give me 2 to the negative 1. Now I will, because it's a negative exponent, move the 2 to the denominator. Let's move down to some of the harder problems here. Here's one that has a lot of stuff. So for the x's alone, I have x to the 7th and a minus 1. So that's going to be equal to the largest exponents in the numerator. 7 minus a negative 1 would be 7 plus 1. And if I look at my y's, the largest exponent is in the numerator. That would be y to the 4, and a minus 2 would be 4 plus 2. So this is going to be x to the 8th, y to the 6th. Over here, I would have 3 to the 3 minus 5. That'd be 3 to the negative 2. 1 all over 3 squared is 1/9. Looking at this one, letter H, I would have j squared k to the 4th. My denominator, now I'd multiply the 3 in, j to negative 3 k cubed. So let's subtract the exponents for the j, the largest one's in the numerator. That would be j, that's not a good j to the 2 minus a negative 3, k to the 4 minus 3. Okay, working on the last two problems. I'm kind of jumping around because the bell was going to ring. This is finished after class. So on the letter K, this 3 exponent will distribute to the negative 3 and the a. So we have to be careful here. The 3, which has a negative on it, that does not affect the exponent. So it's not going to drop to a denominator. This is going to be a negative 3 cubed. So once again, that negative on that 3 is just a sign. It's not going to cause that to drop to a denominator or go over the fraction line. Then that's going to be a cubed, distributing the 3 again. Now I have a to the 9th and a to the negative 7th. So for the negative 3 cubed, that's going to be a negative 27. And then I have the same base on the next 3 terms, so all those exponents would add. I have 3 plus 9 is 12. Minus 7 would be 5, so I have negative 27, a to the 5th. Moving to the letter H, the 2 exponent, because it's a power to a power, will distribute in. I would have c to the 4 times 2, all over d squared. C to the 9th, d squared. So I would end up with c to the 8th, d squared, all over c to the 9th, d squared. So simplifying the c's, the largest exponent is in the denominator. So 9 minus 8 is 1. So I would have c to the 1st in the denominator. The d squareds will cancel, giving me a 1. So I'll have 1 over c.